So today we're learning about how temperature impacts solubility. For a solid thing, so like salt or sugar in a liquid like water, the solubility will increase with temperature. So as an example, you can dissolve a lot more caffeine in boiling water than in room temperature water. And you've definitely experienced this if you've ever tried to make coffee in regular room temperature water. It doesn't work. You don't get a delicious coffee at all. So why is it that you can dissolve more of your solid when it's hot? It's because temperature is just moving particles, and the hotter your temperature, the faster you're moving. If you're a fast moving particle, then it'll be easier for you to break in and break apart other bonds. So if you think about the solid solute, it needs to break apart the bonds between water molecules. Those OH groups in water molecules, they're polar, right? So here's a water O. H, and another H, right? H2O. So that's polar. That oxygen will be a little bit negative. The hydrogens are a little bit positive. That positive hydrogen is going to be bonded to another water molecule over here, right? It feels an electromagnetic force bonding it to this other negative O. There's a hydrogen bond that attracts those two there. So there's a bond of attraction between that H and that O. Your solute has to come in and it's got to break that apart, right? It's got to like burst those two water molecules away from each other and break that bond. In order to do that, it needs a lot of energy. And so that's why a higher kinetic energy or higher temperature, because those are the same thing, will help you break that bond. That leads to these really cool graphs, which are solubility curves for different ionic compounds or molecules dissolved in water. So here's a bunch of them. You can see that when you take, say, potassium nitrate, that's this green curve here. As the temperature goes up, so temperature is the thing on the x-axis. So as temperature goes up, the solubility of all of these solutes goes up. So the solubility of potassium nitrate here is going to go up with temperature. So we can read all kinds of things from that, right? So say we wanted to know, well, what is the solubility of potassium nitrate at maybe 20 degrees? So that's room temperature. Then I go to 20 degrees here, and I go up to that potassium nitrate line. That's the one I've highlighted in red here. And I look, where does that fall on the y-axis? And it looks like it's just a touch below 30. And then look at this axis to read the right units. It's grams per 100 grams of the solvent. So it would be just under 30 grams per 100 grams of water. So you can dissolve at 20 degrees, you can dissolve just under 30 grams per 100 grams of water of potassium nitrate. Now, at 20 degrees, you can dissolve actually a lot more lead-2 nitrate. So that one's up here, right? If I go up to the lead-2 nitrate, that's the yellow line, and then I go over here to the solubility line, I can see I can dissolve maybe 56 grams per 100 grams of water of lead nitrate. But if I go to a hotter temperature for lead nitrate, maybe if I go up to 50 degrees, then I would go to 50 on my x-axis, go up to the line, and you can see that the solubility at 50 degrees Celsius is around 85 grams per 100 grams of water. Let's skip over to those examples that you've got there. You'll practice those in a minute with Miss Krishnan. But let's skip to the solubility of gases, because gases are completely different from solids. So when a gas solute, so say you're dissolving carbon dioxide, you're dissolving that into a liquid solvent like water, that gas has to slow way down. So this example, carbon dioxide dissolved in water, that's the process of carbonation, right, to make a carbonated beverage. The thing is, gases can move around a lot more freely than liquid. So to dissolve a gas in water, you've got to slow it down. You've got to actually decrease its kinetic energy in order to get that gas into the water. So then conversely, if you were to heat the gas and increase its kinetic energy, what's going to happen? Well, the solubility of the gas will actually decrease because you have to slow the gas down in order to get it to dissolve in the liquid. Then if you heat that gas up, you can't dissolve as much. It's not going to be moving as slow enough to dissolve because that fast moving gas just isn't going to be able to dissolve. So the hotter your gas, actually, the less dissolves. If you take maybe a carbonated beverage that's got lots of carbon dioxide dissolved into water and you heat it up, what will happen? It will go flat, right? If you warm up a cup of Pepsi, it's going to go flat because that gas, the carbon dioxide, is going to come out of solution as you heat up the solution. So to summarize there, gas solutes, say carbon dioxide, their solubility will decrease as temperature goes up. So here, the solubility curves are totally the opposite of for solid solutes in water. Here's a bunch of gases, say oxygen gas. If I look at oxygen gas at maybe 30 degrees, so go over to 30 degrees on your temperature axis. Go up and find the green line is oxygen gas. So here it's telling us green is oxygen gas. And then we go over to the y-axis. We can see the solubility of oxygen gas is around 3.5 milligrams per 100 grams of water at 30 degrees. Now, if I heat it up even further, go all the way to 40 degrees, then the solubility of oxygen gas goes down even further to maybe around, if I look at that, that looks like, if I try and do a straight line, around 3 milligrams per 100 grams of water. So solubility will actually decrease as temperature goes up for gases.